Okay. Hello, thank you very much. I'm very happy to be here with you. I will start sharing my presentation, which is called Imagine Futures, Ethical Scientific Challenge of Precision Medicine in Argentina. Let's see. Okay. Well, genomic developments impose many challenges for health outcomes in this region, and although the prediction seems optimistic, with more access dedicated to healthcare in developing countries, access to precision medicine will face barriers to social inequalities, insufficient health population infrastructure, and the need for more training initiatives for healthcare providers. And further, it is argued that the greatest ethical and scientific challenges surrounding the clinical implementation of precision medicine is the lack of diversity in genomic databases. Looking at the global gene therapy trial distribution, it can be observed that clinical studies evaluating safety and efficacy are performed mostly in high-income countries, and almost two-thirds of gene therapy clinical trials target cancer. Worldwide, about 70% of cancer deaths occur in low and middle income countries, and cancer incidence will increase. There is a great uncertainty worldwide regarding the economic modeling of gene therapies, but the cost is not the only challenge for improving access. The supposed benefits of high-cost technology are not applicable when they are applied in healthcare systems that are highly fragmented and with significant budgetary limitations, which must first define priorities and essential services. If precision medicine is the pathway to improve future health outcomes, how do these innovations translate into a context where the basic needs are still unmet? And based on critical assessment of life sciences and genetic developments, I wonder which health outcomes might we expect and which ideas about the futures are promoted by these innovations. I think that these questions are best addressed from an epistemological framework that deals with the global-local connections from a situated knowledge perspective. The notion of situated knowledge was coined by John Haraway in 1988 and works on 4 levels simultaneously: epistemological, ontological, ethical, and political. It addressed the questions of objectivity in science, and it requires that the object of knowledge be pictured as an actor and an agent, and not as a screen or a ground or a resource. She calls for partial, locatable, critical knowledge, sustaining the possibility of web of connections, called solidarity in politics, and shared conversation in epistemology. Haraway would say that the moral is simple: only partial perspective, promise, and objective vision. And these shifts underscore that situated knowledge is more dynamic and hybrid than other epistemologies that take the position of the knower seriously and involves mobile position. There are 2 ideas of Haraway methodology that I would like to keep in mind for this presentation. One is the possibility to envision inclusive futures by engaging in modest practices, and the other is the question of how we see things. For the first time in our history, drones allow us to see from a different perspective. This is what a neighborhood in the north part of Buenos Aires province looked like from the air. The photograph is part of the project called Unequal Scenes, and it's quite illustrative of the borderlines that separate our global south communities. I think that our approach needs to foster the capacity to see from the peripheries and the depths. As Haraway reminded us, situated knowledge are about communities and not about isolated individuals. Situated knowledge also demands a practice of positioning that is about carefully attending to power relations at play and in the process of the knowledge production. A concrete example of these power relations is the underrepresentation in genomic databases. According to the GWAS catalog, 79% of all GWAS participants are of European ancestry, despite making up only 16% of the global population. And the lack of population diversity is another example of the bias and the asymmetries of power embedded in the construction of the map, where emerging genomic knowledge and the resulting products and therapies may not translate to communities underrepresented in the biomedical research, and this could lead to poor prevention strategies. In this sense, an interesting point has been made in this analysis from the policy landscape from a Latin American perspective that calls for broadening the scope by imagining mappings not limited to the nation state, but looking at these circuits of use within and across countries and regions. I think that the actual trends in cross-border reproduction and international mobility seeking reproductive services are a clear example of why local and global perspective must be observed carefully. So after this short introduction, I will show you now 4 different cases of precision medicine in Argentina. 2 main targets with recent developments in terms of resource allocation and strategic population objective, clinical trials for cancer treatment and rare diseases. Considering as an example the recently approved gene therapy for spinal muscular atrophy. And there are also, I will then briefly comment on 2 initiatives. The first one related to ethical implications for polygenic risk score in the context of in vitro fertilization, and a national initiative that aims to create a public biobank to support biomedical research in Argentina. Cancer is the leading cause of death and disease in Latin America and the Caribbean. There are currently 13 studies recruiting patients in Argentina. 10 of them are for cancer treatment and 3 for rare diseases. And according to Piñeros, the cancer burden in Latin America will increase by 67%. And the ongoing clinical trial studies target the most common cancers in this region and other conditions with poor therapeutic outcomes. But the question is that if patients can expect any other benefit rather than participating in clinical trials. For the case of gene therapy, the first gene therapy approved in Argentina is Zolgensma for treating patients with spinal muscular atrophy. SMA is a serious genetic condition that affects the muscles and causes problems with movements. It's one of the most common genetic conditions that affect children, and it gets worse over time. Type 1 SMA is the most severe type and accounts for more than half of the cases. The Argentina National Commission for the Evaluation of Health Technology has recently published this evaluating report analyzing this novel therapeutic option. And last year, the case of EMA reached the public when an international campaign started to collect funds for treat her for SMA. And one of the geneticists I interviewed at that time, he told me, what I feel about this girl, Emma, obviously I was happy for her because thanks to the social media campaign, she was able to collect the money to pay for the treatment. But I also feel infinite sorrow for the parents who have children with the same conditions and did not make it. I'm sure that there were dozens of parents because this disease is relatively common. So the state tries to tackle the equity problem by implementing novel financing schemes such as the shared risk strategy, which guarantee that the payment will be made if the drug works. The role of the statement as the only buyers of this high drug technology should be carefully analyzed. Well, finally, there are 2 initiatives that might help to picture the future challenge of precision medicine in Argentina at an individual and a population level. On one side, the development of reproductive genetics, mainly private, and is concentrated in the metropolitan area of Buenos Aires, where the majority of the fertility clinics are. Since 2013, access to reproductive technologies has been covered by the legislation for heterosexual or same-sex couples and single persons, but pre-implantation genetic testings are not included in the coverage. In the private clinics, patients can access almost the same services they can get in high-income countries, even those that might not apply for the Latin American population, such as pre-implantation genetic tests for polygenic conditions. Considering only embryo selection for medical traits, I wonder if can PGTP help prospective parents to make better choices. The first logical step to discuss clinical applications would be to know our genetic backgrounds. So understanding the genetic and environmental map of our population is a strategic objective to lay the foundations for populations-based health policies. POBLAR is a national level initiative which aims to create a public reference biobank to support biomedical genomic research in Argentina. The genomic characterization of population is useful for many issues, but most important for the design of a national program of genomic medicine in the country. So after, this is the last slide, Argentina's history of genetics is tightly related to forensic developments and applications that contributed to solving identity crimes performed under the civil military dictatorship that occurred during 1876 and 1883. And thanks to the persistent fight carried out by the grandmothers of Plaza de Mayo, in 1987, the National Bank of Genetic Data was created This initiative was unique in its kind, and it enables the identification of children whose parents were kidnapped or assassinated. And the Grandparenting Index was a milestone in Argentinian history and a great example of science in service of the human rights. At present, from the analysis of these different case scenarios, it can be concluded that the scope of precision medicine in this region will introduce challenges, not only in terms of access, but also with regard to how the notions of health, disease, and risk are understood. Therefore, new approaches should be developed in order to generate equity and community engagement for the future. Do we have the wit to stay on top of and in control of our innovations? Thank you very much.